we're very, as I said, we were very fortunate to be allowed to use this facility. As you can plainly see, all of the equipment that we need to do chemical testing is laid out here, and it saved us a lot of time. I have been involved in a couple of times where we did it right at the stream side, and that can be an ordeal, especially when you have cold weather. So we're very fortunate that we have this facility. The phosphate is Harv is going to be doing over here, and he's an expert at it.
Well, why don't you tell me what you're doing, Harv?
Well, obviously you use our sample water that we got out of the stream. And the beginning of the process to test for phosphates is to get 20 milliliters of this and add potassium persulfate, pack it. And you add the packet, of course, shake it. And very honestly, we have the directions here, so to speak, as if we get confused, we look at, and I look at all the time. You need to add sulfuric acid solution, 2 milliliters of that. And all this goes into testing, again, how much phosphate is in the water, which is another indicator of the health of the stream. Phosphate's one thing that adds phosphate to the water at least in the older days, phosphate in detergents. Now, most of it comes more from fertilizer runoff, and obviously we have a book that tells the certain parameters as to which amount is detrimental to the stream, and we've been lucky that the Yellow Breeches and the streams that we test have been within the recommended limits. And so the phosphates have not been a problem locally as far as being too high. The final reading for the phosphates uses a little device called a comparator. It's a rather unique little thing that has a disc. And you notice, you can perhaps see that the color goes from a darker to a lighter shade. This disc is inside the device, the comparator, and in the 2 openings at the top are these 2 test tube-like devices. That on the left is the regular stream water. In other words, nothing has been added. So that's in the left, and the word comparator, I assume, is, as the name implies, comparing 2 samples. So on the left is the stream water with no chemicals, not the phosphor and the potassium persulfate that we added. Now the prepared sample that has the chemicals added to test for phosphates is inserted into the right compartment, and then you need to look up at a source of natural light preferably and try to match up the 2 colors. And it is not a dramatic matchup, but as you go down here, I get a reading of about 7. In other words, that's an indication from predetermined charts. We take that 7, and as the directions say here, we divide by 50, and I'll have to do that. That gives us a reading, and I can tell right now that that's well within the lower range of phosphate readings. And of course, Art records this each time, and this again shows that phosphates are not a problem in this particular stream sample, on this day anyhow.
Okay, now we're going to check the pH of the water now, and we have a buffer that we use which is 7.0, and that means that that's good with the pH. So here's the meter that we're going to use, and First off, what I do is make sure my meter is calibrated. So I'm going to put that into my buffer sample. And I have to let that set for a few minutes for that to calibrate. All right, now I have it calibrated. I'm going to put it right down into the sample water, and we'll have to let that rest now for a few minutes until we get our reading. Okay, now I'm going to check the stream conductivity, and I'm going to use this sodium chloride to calibrate my meter, and when that's calibrated, then I will put that in the sample.
Another test that we do is for alkalinity. And alkalinity has to do with the ability of a stream to neutralize acids. Alkalinity is influenced a great deal by the stream bed itself and the rocks and the chemicals that are in the water. The first step was to fill a small test tube like glass vial that has a predetermined amount of liquid, and that was put into our other larger jar, and we add a pillow of chemical testing material called bromsconol green menthol red pillow. That's added. Swirl the solution, and you notice it is green or dark green. And from there, we drop one drop at a time, a solution of sulfuric acid until the green color disappears. And this is the test for alkalinity. And we'll see how this works. 1, 2, 3, and eureka, there it is, nice and red. So it was only 3 drops. I'll give it another one just to see if there's going to be any change. 3 drops is all it took. And with that information, we take that number of drops and multiply by 20. That gives us a number in looking at predetermined charts. We can then determine and record what the alkalinity of the stream is. So obviously 3 times 20 is 60, and Art will look at the chart, but I'm sure that's within very acceptable range for alkalinity.
Okay, we on each site, after we get the results, the chemical results, we fill out this form which gives the results of each of the chemical tests that we do. In addition to, we record the air temperature, we look at the condition of the stream bank, and give a description of any problems in the stream bank. We also record the precipitation that might have occurred on that day that we do it and on the day before. And we look at the water appearance to see whether it's clear or whether it has some cloudiness or other colorations. We check the water odors, and we check the soil odors, and we look to see the sediment, if there's any additional sediment deposits.
Where does the data go then?
Okay, then after we finish this up, then we give the forms to Jim, and then he records it on our website. You know, I'm excited about this because it shows over a long period of time what is happening to the stream at that site. And we have done I should say Jim Haney has done a study on some of the spots at Yellow Breeches, and used that data to come up with a trend. I think our next project is to go back to as far as we have the data and do a trend analysis of the whole thing. And it's interesting, just from a layman's point of view. It appears to me that the nitrates have been slowly rising. You know, you can think of a lot of reasons for that. You know, the most popular opinion there is that, you know, is using more fertilizer, and but it's kind of hard to, and there's more development of the land around the particular sites that we're doing. So I think that you know, at some point in time we need to educate the public even more than we're doing now.